My dear students, today I am going to discuss the new things, new topic. Okay, let's go. Before going to learn the matrix, I am going to show you what is the uses or application of the matrix. That will help you to know the matrix very nicely. Okay, the uses of matrix is the first one. Matrices are used for the plotting graphs, statistics. Okay, that means for plotting any graphs, you must need the matrix. Second one, to do scientific studies, research in all different fields, you need the matrices. Also, matrices are also representing the real world data like population of people, infantile mortality rate. That means the matrix or mathematics is related to in our real life. So now you know that how many uses or application of matrix. Okay, now go for the definition of the matrix. A matrix is formed by arranging some numbers or some alphabets or some value the form of rectangle or square shape enclosed by square bracket or curved bracket. And in the down you can see the definition. Here A is the matrix and it is enclosed by either the curved bracket or you can see the first bracket or the third bracket or square bracket. Okay, and inside the things A, D, G, they are the elements of the matrix, and A and B are called the name of matrix. That means for every name of matrix you have to write the capital letter, and for representing the elements of the matrix you can write a small letter on the number. We go for the next, name and elements of matrix. So here A and B are the name of matrix I told just now, and A, B, C, D or 1, 2, 3, they are the element of matrix. Okay, so this is the matrix name and the elements of matrix. Now every horizontal line, this is called the horizontal line. AD is a horizontal line, it's called the row of this matrix, and every vertical line is called the column of this matrix. Got it? Every horizontal line like A, D, Z, B, E, H, number 1, 2, 3 rows. Okay, so how many rows in A matrix? 3 rows. And again A, B, C or D, E, F or G, H, they are 3 columns because they are the horizontal line. Okay, now we are going to learn order or dimension of a matrix. Suppose if the number of rows is m and the number of column is n, then order of matrix can be written as m cross n or m by n. It is read m by n. Okay, let's see. The A matrix is given. You can see that here number of rows equals 3 and number of column equals 3. That's why order of this matrix, it will be m by n, or you can write also a 3 by 3. Both are correct. In two ways the order can be written. I hope that you understood. Order of A equals m by n. This cross means by. Okay, also you can write the order or the dimension of the matrices by its name. Here is the matrix, that's why you can write. So here just look at the look here in the name of order matrix, first one will be the here the first one will be the row and the second one will be the column. If I see you like this one will be the rows and this one will be the column always. If I write m and n, okay, so this will be that. Understand? Also we can write 3 by 3. This is not m by n, but finally we have to write 3 by 3. Okay, because number of rows equals 3 and number of column equals 3, and order of A equals m by n. It's only the formula. Also I can make it okay, wait, if I write here, then you will understand that. So it will be 3, it will be 3, and for your understanding I wrote m by n. So both are correct. Okay, I hope that you understood these things. So now go for the next line, position of elements. Okay, we have to know position of elements. That means in every matrix there are some elements, but every element has a position. I'm going to that. Here I wrote A and A11. So A means the name of the matrix and A11 means the position of the elements. Whenever you will see any A alphabets, it means this is the name of matrix. But whenever you will see A11, okay, it means it is not the matrix names, it is the elements of the matrix. A11 means position of one number row and one number column. Okay, the elements, one number row and one number column, it's called the here is A11. Similarly, if I write A31, that means the elements in 3 number rows and 1 number column. Okay, now go for the next. Here it is written that this one is the name of matrices and it came later, no problem. Okay, now I'm going to find the elements. Suppose that A equals A, B, C, D, E, F, and just I wrote here A, B, C, D. It may be any number 1, 2, 3, 4, 5, 6, 7, 8, whatever it is. So now tell me A11 equals which elements? A elements. Okay. Whenever I will say A11, that means it will be this position. A21, 2 means number 2 rows and 1 number column. So go for the rows first. First one will be the row, second one will be column. And we have to count first row, then go for the column. Okay, so this is the two number row and now a 1 number column. That means is denoted or indicate the elements B. Now the another, this is the 1, 3. 1, 3 means 1 number row and 3 number column. So go for the, this is the 1 number row. Okay, this is the 1 number row and 3 number column. This is the 3 number column. So it's denoted the Z. So I hope that you understood what is the elements and what is the matrix name. Okay, now I'm going to discuss different type of matrix. Okay, first of all, square matrix. If I show the example first, then you will understand. Here you can see that the number of column and number of rows are same. Okay, square means all square, all rounder, like that. So whenever the number of rows and number of column of a matrix will be same, it is called the square matrix. So here number of rows is 3 and number of column is 3. That's why A is called the square matrix of order 3. Okay, so number A is the square matrix. Now I'm going to discuss Aij, where I equals j means. Whenever Aij you will see it is the position of element, but Aij where I equals j means A11, A22, A33 elements. Okay, the elements located A11 position, A22 position, and A33 position. The elements of first row, first column, similarly second row, second column, and third row, third column. Why do you need? For knowing the definition of the principal diagonal. You know that diagonal means like that. If I show you here, diagonal means, wait, yes, diagonal means like that. It's the diagonal, and another diagonal is like that. So first one, the first one will be the principal diagonal, because this diagonal goes through the A11 position, A22 position, and A33 position. That means Aij, where I equals 8, means that it's the leading diagonal or principal diagonal, or the main diagonal. Okay, this is the main diagonal or the major diagonal, and the another one will be the minor diagonal. Okay, so now we have learned that this is the diagonal elements. We have to know, because for the next know the next definition. Okay, so no problem. We are going to the next definition, and AE are the diagonal elements, and it is show like that. Okay, so let's know the diagonal matrix, and in short form it can be written as DN. I'm first I should show the example. Here you can say that only main diagonal elements are non-zero, but all other elements are 0. So whenever you will see this type of matrix, it will be the diagonal matrix. And a square matrix always must, it will be the square matrix. That means row and column will be same. Otherwise, it cannot be the diagonal matrix. Okay, that's why a square matrix with every elements in the principal diagonal is non-zero, and the other elements are 0. And here that only the principal diagonal elements are non-zero, all other elements are 0. This is the diagonal matrix, but it must be the square. That's why it is given a square matrix. Okay, so now scalar matrix, very interesting things. For scalar matrix like that. That means whenever the elements of main diagonal or principal diagonal will be same, a 2 2 2 3 3 3, and all others element will be 0. Okay, that's why definition is given like that. If the non-zero elements of a diagonal matrix are equal, it's called the scalar matrix. Understand? So a will be the different things, 2 2 3 3 5 5 1 1. If a is 1, it has the another name. That's why we have heard a equals 1. I am giving the another example. B is a matrix, 2 2 is also the scalar matrix. That means the diagonal elements will be same and all others will be 0. Okay, very interesting. So all other elements will be 0, but diagonal will be same. That's why if the non-zero elements of a diagonal matrix are equal, okay, if the non-zero elements of a diagonal matrix are equal. So first of all, you have to see the figure, you have to see the example, then go for the definition. It will help you. Now identity matrix is very important things like previous. Okay, this is the identity matrix. Look here, you can see that all leading diagonals or all diagonal elements, principal elements are 1, same but 1. If it is 2 2 2 3 3 3, it is the scalar matrix. But if it is 1 1 1, also it is scalar matrix, but it has the another name. It is the identity matrix or unit matrix, and it can be written as I3. I3 means 3 by 3 order identity matrix. Okay, and it can be written as I and I3. Similarly, it may be 2 by 2, 1 1 1. So what you can see that every diagonal, these diagonal elements will be 1, only 1, no other. If it is 2, it has the another name. Okay, identity matrix. Now null matrix, if all elements are 0, is called the null matrix, and the value of null matrix equals 0. Value of identity matrix equals 1. You have learned just. Now I am going to give the idea about addition and subtraction condition. Condition of addition and subtraction, that first condition, if A and B are the two matrices, then A plus B or A minus B will be possible. Okay, if order of A and B are equal. Order of A and B are equal. Order must be equal. That means number of rows of A and B will be equal, and number of column A and B will be equal. Listen very carefully. Number of row A and B will be equal, and number of column A and B will be equal, will be same. Then they can be added or subtracted. And another condition, same position of the elements will be added or subtracted. Okay, now I am going to explain it. Examples: if A is a matrix 3 by 3 order, also B is a matrix, it is the how many? Also B is a matrix of 3 by 3 order. That's why you can see that this is the row. First matrix of row of first matrix equals 3 and row of second matrix equals 3. So they can be possible. Again here look at the C and 3. So you can see that first matrix is 2, second row of first matrix is 2 and row of second matrix is 2. So row are equals. Now look at the column. So first matrix of column and second matrix of column equals. That means their order are equal. But look at this one. Here row of the first matrix is 2, but row of the second matrix, that means matrix F, is 3. Similarly, column of the first matrix equals 3, but column of the second matrix equals 2. That's why their order are not same. For that, we can say that E and we can say we can say that here E and F, sorry, it will be E and F cannot be added or subtracted. Got the point? Their order will be same. Look at the number E and F. First row, the number of rows equals 2, and here number of rows equals 3. Here number of column equals 3 equals 2. That's what it cannot be possible. Okay. So now just I am showing you how to add. So if A and B are possible to add, then I told you same position will be added. That means A11 position and B11 position will be added. A12 position and B12 position will be added similarly. Okay, so when we learn the addition, I'll make you understand more clearly. Now, condition of multiplication. Condition of multiplication is different from the addition and subtraction. You know that whenever you will add or subtract the fraction, and addition of and subtraction of fraction and multiplication are the different. Okay, so similar things here, multiplication are the different. Condition is that if A and B two matrices, then AB is possible. That means they will be multiplied if the first number of column of first matrix, number of column, listen very carefully, number of column of first matrix, the number of rows of second matrix will be same. Column of first matrix equals, it will be little bit difference. And previous just we started our talking by rows, but here for multiplication, number of column of first matrix, that will be same the number of rows of the second matrix. Here you can see C, and look at the C and D, number of column is 3, 1 2 3, and look at the D, number of rows equals 2. So number of column and number of rows are not same. That's why we cannot multiply them together. Okay, condition is that here number first column and row will be same. Column of first one and row of the second one will be same. Otherwise it cannot be. Okay, that's why C and D are not multiplicable. Now look at the another one here. Number of column of first matrix is 3 and number of row of the second matrix is 3. Column and row are same. That's why they can be. Okay. Now, at last, inverse matrix. If the different determinant of a matrix is 0, matrix has no inverse matrix. Okay, and inverse matrix equals adjoint matrix of A divided by determinant. Always will be adjoint matrix of A divided by determinant. Dear students, today just I wanted to show you the basic information of the matrix, and inshallah I'll give you video exercise by exercise, and that time I will discuss more things very clearly. Okay, so Allah Hafiz, no more today, inshallah. See you again with the next content, that means exercise 1A, and till then, Allah Hafiz.